Let's start with question 1. This is the first question on the worksheet on chapter 5. So if you are watching this, then you definitely want to have the worksheet in front of you. So we're going to start with this question. You are given the isotopes of sulfur, and you need to determine the relative atomic mass. Now, first of all, you can see here that you have these numbers, which we call the mass number. And it is very important that you remember that mass number is not the mass of the atoms that you will use. Mass number is the sum of the number of protons and the number of neutrons. So it is always going to be a whole number. But the actual mass of the atom may be slightly different because the mass of each proton and the mass of each neutron is not their masses are not exactly one. So that's why when you determine the relative mass of these atoms compared to carbon 12, they have their decimal places. So you are given the relative isotopic masses. So I'm just going to do a little summary here. For sulfur 32, the relative isotopic mass is 31.97. And the percentage abundance is 95%, which is the same as 0.95. So it's entirely up to you whether you want to convert it to decimals or just keep the percentages, as long as you understand what it means. So for 33 sulfur, the relative isotopic mass is 32.97, and the percentage abundance is 0.77%, which is the same as 0.0077. So if you want to know how to go from the percentages to decimal, all you need to do is to divide the percentage by 100, which is where the percentage comes from. So for the third one, I have 34 sulfur. Then the relative isotopic mass is 33.97, and the percentage abundant is 4.23%, which is the same as 0.0423. Once again, you are allowed to keep the percentages. It just means that you have to divide the number by 100 later on. So in order to find the relative atomic masses, now this is me being quite bad. The actual notation is supposed to be IR, I think, but I never use it. And to be honest, it doesn't really matter. It's easier to call it this, but I think it's AR, so relative atomic mass. It's gonna be the mean of these. So you have to multiply the first relative isotopic mass with its abundance. Am I gonna have enough room? Okay, probably not. Let's try again. So AR, which is relative atomic mass, is going to be 31.97 multiplied with 0.95 plus 32.97 times 0.0077. I think I still don't have enough room, so I'm going to squeeze it at the bottom. Hopefully you have more room than this. 33 times 97, 33.97 times 0.0423. Okay, now you are welcome to do this calculation by hand, but you are provided with or you're allowed it, you're not going to be provided, you have to provide your own, with a scientific calculator. So make sure that you bring it and be careful when you do the calculation. And I am doing it right now, which is why I'm not writing anything. All right, so my answer, hopefully I didn't time anything wrong, is 32.0623. We're not going to discuss decimal places or significant figures yet. So I'm just going to go with that. This is the correct number of significant figures that you have to do for this question. Actually, no, you have to go back. It's actually this, but don't worry about it. And you can leave the answer as it, and it's perfectly fine. And you do not need a unit because this is a relative mass. So that's question 1.